Welcome to another episode of Machine Learning Made Simple. This is where we break down cutting-edge AI concept into simple, useful ideas you can actually use and apply. Today's topic might just change how LLM interact with everything. We are talking about Anthropic's Model Context Protocol, or MCP for short. It is taking the world by storm. Is this the end of tool-specific APIs, or is it the beginning of a universal LLM interface? But before we can dive into that, we'd be remiss if we didn't mention GPT-4's latest release just last week. OpenAI launched a new update, clearly aiming to go head-to-head with Anthropic. Their upgraded GPT-4 model can now perform image editing with just natural language prompts. Yes, you heard that right. You just describe what you want and GPT-4 can edit that image in the way you want. It is like giving GPT a paintbrush and watch it turn your words into edits. It's like Photoshop on steroids. It is a bold move that signals just how fast this space is evolving. And this might be the beginning of the end of AI apps. Or is this the beginning of something even bigger? Let's unpack it in the next segment. So here is what happened. OpenAI rolled out a new image editing feature in GPT-4 integrated into ChatGPT, and almost instantly everyone started creating their own Ghibli-style portrait. So that part, fun, but it opens the doors to something way more powerful and problematic. We're entering a new era of AI-powered image editing, and this isn't just Photoshop with a sprinkle of AI. This is fully natural language-based image editing, baked directly into the model. You don't need layers or masks. You don't even need to know what a layer is. Just type what you want and it happens. Let's break this down. What this does is democratize the image editing in a way we haven't seen before. Want to turn your selfie into a Lego scene? Or a cyberpunk painting, or a Pixar style headshot? You got it, all in one prompt, one single prompt. All of these things can happen. This used to require complex workflows using Comfy UI. If you're familiar with Comfy UI, to where you use Stable Diffusion model or Flux models from Black Forest Labs and add LoRa's, low rank adapters, which are fine-tuned to produce those stylistic transfers, or IP adapters, control nets, and all those things. Now, just a single prompt will achieve all those things. Remember when the Instagram filters first came out? Everyone suddenly became a photographer. That's what GPT-4 is doing to design. It's handing out power to everyone. And while that is amazing, it also changes the playing field completely. But here's the thing. It doesn't replace Comfy UI, not even close. Comfy UI still rules when it comes to precision. If I want the image of a robot working at a desk in a library, prompt adherence, contrast, composition, all of those things can be achieved. Not with GPT-4. I'm going to use Comfy UI, full stop. GPT-4 is very good for quick and dirty results. Casual users love it, but it's not high fidelity. And yet, for most people, it is good enough. And that's what makes it dangerous for developers, because what this new feature really does is make entire categories of apps obsolete. You know, those aging filter apps, the ones that turn you into a senior citizen or cartoon character. They're all gone. Just one click in ChatGPT and you can get the same result. And that's the OpenAI effect. No low-hanging fruit stays low for very long. If you have an app idea, you have a niche that you want to conquer, by the time you get your product up and running, it's gone. So let's zoom out for a quick checkpoint. So far, GPT-4 is handing out creative power like candy, but that power comes with a catch for developers, for privacy, and for the future of small tools. Let's look at this more closely. If you're building a startup around a single AI feature, whether it's personalized job cover letters or text-to-image filters, there is a good chance that OpenAI will just add that feature themselves. Then what? It's not just about product market fit, it's about product durability. And now, sure, there will be still opportunities. Comfy UI enterprise services, for example, still requires GPUs, orchestration, and scale. That space is safe for now, but casual B2C models, they are very vulnerable. And here's the thing, building these apps aren't easy. Even if the model is open source, you will still need infrastructure, compliance, data handling, compliance handling, GPDR, scalability. Just because you have 3 users today doesn't mean that you can ignore what happens when you get 3,000. So you have to build an app that can scale to 3,000 or even 3 million users. Just to build that orchestration pipeline requires deep architecture knowledge. You need to hire engineers who can build that for you. It will cost thousands and thousands of dollars just to put that in the cloud infrastructure, just to have like 3 or 4 users using it. Maybe not 3 or 4 users, I'm exaggerating, but very few users to justify the price, because the whole idea of building that infrastructure is that when you scale, you get millions of users, and those you'll reach a break-even point. But the problem is that OpenAI will release that feature before those startups can reach the break-even point, and that's the problem. So I always tell founders, be brutally honest. Your app might be cool, but is it defensible? Will it survive when big enterprises like OpenAI rolls out a new version that does 80% of what your app does for free? Because when that happens, most users don't switch. They don't care that yours is better. They care that ChatGPT is faster, simpler to use, and already installed. And this is what pretty much ruining the small businesses. And OpenAI is not helping. Microsoft succeeded because it built platform. So did Apple. They created ecosystems. They let developers build on top. And Kevin Kelly, if you read his book, amazing futuristic view in his books, he called this out in 2009, that platform as a service was popularized as a result. And the whole point is that platform as a service creates a thriving ecosystems which benefits both the developers and the platforms on which they develop. It's a win-win system. And remember old Microsoft, you could build a $5 sound editing app and sell 500 copies. That paid your rent, and that created entire microeconomies built around Microsoft operating system. But when Microsoft changed their business model and they locked it down, the developers left and Apple embraced them. And that's why the Apple App Store became what it is now today. Hardware plus software plus platform. They have a huge moat. Apple has such a big moat just because they created the business model. In fact, they took it from Microsoft, and Microsoft kind of lost its way, essentially gave up their market share to Apple, just giving up that platform as a service that they had as a business model forever. I mean, they probably didn't realize they had the business model when Bill Gates started it, but they stumbled upon it and then they handed it over to Apple. But that's fine. Now let's compare that to OpenAI. They launched custom GPTs just to take advantage of that kind of a platform as a service model. That sounded promising, but it flopped. Why? Because a few prompts don't make a product. Unit workflows, logic, persistent, and custom GPTs that they were peddling on the platform didn't offer that. I mean, it really didn't work. So now they're back to chasing features. Image editing is the latest one. And yeah, it's cool, but let's be clear, it is not Comfy UI. Even beginner level Comfy UI workflows still outperform GPT-4's image editing results. And here's my real issue, the Appleification of AI. Everything's hidden behind some kind of a GIF wrapping. I mean, you don't even have to ask, but users aren't dumb, especially technical ones. And that's why tools like DeepSeek and Claude are gaining traction. They show their reasoning, they expose intermediate steps, they make the user trust them. OpenAI already had that capability. They just didn't show it. They chose not to show it because they assume the users didn't care. I mean, why would you make that assumption? The technical user, the people, that demographics that use OpenAI, ChatGPT, these are not regular people. These are technical users. They do care about those reasoning steps. They're early adopters. You have to cater to these people. Yes, there are 3 groups of people who use OpenAI now, broadly speaking. There are these casual users who use ChatGPT for blog posts, summaries, and social captions for the social media posts. And then you have a huge group of students who use it for learning, and GPT is of course a great tool for learning. It is such a big language model. It has so much knowledge encapsulated that it's very good for study. However, this is also the most expensive demographics that OpenAI is sustaining, because these students, they burn through the tokens for homework, help, and research. They do hours of research and only maybe for $20. And they are the largest user for the GPT models. And when GPT raises their price, these are the people who are the first one who are going to migrate to DeepSeek, because DeepSeek is like 10-20 times cheaper. I'm talking to students who are already migrating to DeepSeek. They still keep OpenAI on the side because it's still under $20. The moment OpenAI raises their price, the students will be gone. Third group are the professionals who use it occasionally for specific workflows like legal drafts or copywriting. And this is this third group, the professionals that OpenAI needs to win back. because casual users are usually fickle. Students are price sensitive. Professionals, they will pay as long as it's useful. And that brings me to pricing. Right now, the pricing model is broken. A flat fee for unlimited use, it's a loss leader. It creates hype but kills margins. And in fact, that's what Sam Altman has been saying for a while now. They really need to increase the price. In fact, they have this $200 a month model that they're selling. Who can afford that? That's insane. And he's talking about moving the entire platform to the $200 a month model, and that's insane. So here's my suggestion: adopt the internet data model. So $20 a month gets you, let's say, 2 million tokens, and after that charge $5 extra for every extra 100k tokens. It's transparent, predictable, scalable, and that's how most of the internet providers work. Like you have, let's say, 4 terabytes of data that you can use a month. They call it unlimited, but if you read the fine print, it's 4 terabytes because I use a lot of data, so I know. And if you go beyond 4 terabytes, every 250 gigabytes, they charge you $10 or something. So that's a good model. I mean, it incentivizes people to restrict their overuse and be reasonable in their use, because it's also harming the environment. With the more tokens that are generated, the more carbon dioxide gets into the environment. So let's pivot now to something I've been seeing a lot lately: people uploading terrible selfies and asking GPT-4 to generate professional headshot. And that's a good use case, and are doing it. They're posting videos on LinkedIn. They're crazy that, oh, I found this great workflow. You can upload and get these professional headshots done by GPT-4. And that's one of the things that one of those Insta headshot AI app, it's now gone, because you don't need those AI apps to generate your professional grade headshots from your selfies, because GPT-4 can now do it. That's another app that's gone. So you know what? It works. Sort of. Fine. Go generate your headshot. But it is a privacy landmine. And here's the thing. People think they already scraped my LinkedIn profile, my social media post. So what's the harm? But scraping public data without consent is illegal under GDPR. If the companies who runs those AI models or trains the AI models, they scraped your face or your personal photos from social media and trained their models on it, that's a lawsuit waiting to happen. However, the moment we ourselves upload our own photos, personal pictures willingly, we have given them the consent to use our data. And here's what we are agreeing to. Our images can be stored, our data can be used to train future models, our browser history, our even battery history can be used to train and find a psychometric model of us. Your battery levels and how often you charge your phone can tell a lot about your psychometric profiles. Like people who have addictions tend to not charge their battery that often. I mean, that's a weird correlation. The machine learning models found it. I mean, you can predict they're going through depression, whether they're charging their phones regularly enough or not. I mean, they can build an entire psychometric profile on you just from that interaction that you do with the large language models. Most people don't read that fine print, but I have written those end user license agreements, and I kind of know how this all works. Unless you are on an enterprise plan with a signed data protection agreement, assume that everything you upload, all interactions are fair game. So yeah, it's fun and your grandma might love it, but if you care about control, quality and privacy, you are better off running your Comfy UI models locally and stay off using GPT-4's image editing capabilities, at least not with your personal photos. Comfy UI is private, it's powerful, and it doesn't quietly harvest your face. So thank you OpenAI for another shiny new feature, but we kind of don't need it. We'd rather have the Model Context Protocol. That is a much better tool, and that treats us like builders, not just data points. And if you're curious about how MCP actually works, stick around. We're going to dive into that next. Today's main topic is taking the AI world by storm. It's called MCP, the Model Context Protocol, and it's quickly becoming one of the most exciting and important developments in the AI tooling ecosystem. If you have been following the evolution of tool use in language models, you're going to love where this is headed. But before we dive into MCP, let's rewind a little and look at how we got here. It all started with LangChain, the first big framework that gave language models the ability to use external tools. LangChain introduced orchestration, chains of logic, agents deciding what to do, and tools, external tools that executed the work. For example, if you want to search for something, it has the search functionality that gets integrated separately, because the large language model a year, 2 years back didn't have that capability. If you want to use a calculator, that's an external tool that LangChain provided. If you want to database connection, if you want to the RAG orchestration using a vector database, LangChain provided that support. So all those tool calling functionality was provided by the LangChain orchestration. It was powerful, but also it was messy. You needed a lot of glue code, and you needed engineers to do that routing logic and manual configuration just to get things working. And then came Toolformer, a research project from Meta that flipped the script. Instead of orchestrating the tool use manually, Toolformer pioneered the use and fine-tune of the model itself to decide when and how to use tools. It used self-labeled examples to teach the model to choose the right tool to use based on the context, and the result was a smarter, more autonomous model that didn't rely on brittle chains of logic that you have to hand code. But even Toolformer had a ceiling. It only worked with tools it has seen during training. If you wanted to integrate something new, a private API or a new API that was not available during the training time of Toolformer, you are back to square one. And that's where MCP comes in. At its core, MCP is like a universal translator for AI. Think of it like a USB plug. It gives the language model a way to talk to any tool, whether it's a weather API, a 3D rendering engine like Blender, or a stock price database. Even if the model has never seen that tool before, it can still be able to call it and interact with it directly. Now, how is this possible? Instead of being trained on every possible integration, the model speaks a shared protocol, a handshake, a common set of expectation. Right now, the shared language is JSON, and if you have used it, you probably know what we are talking about. But if you're not familiar with it, then don't worry about it. It's just a data structure that can be shared in a very structured format. The key isn't the format, it's the structure. The MCP creates a standardized way for models and tools to communicate. No matter how new or custom the tool might be, the communication protocols remain the same, just like the TCP/IP protocol. I mean, this is TCP/IP for AI. Think about it. And here's how it plays out in practice. So let's take an example. On the model side, you got an MCP client, basically an adapter that helps the model understand what tools are available to it, and you have to integrate that part manually. So for example, if you have an Anthropic client or a Claude desktop client, you have to add the tools manually. It's just one click add-on and just gets added. And then it knows what these tools can do, what services are available to it, and how to use the tool. And on the tool side, which is called the MCP server, a wrapper which describes the tool's capabilities in a clear, structured way must be written, and not just send me requests, but here's how you can call me, and this is the standardized processes, and these are the tools and services I'm providing. And this is the structured way of calling me, and this is the response. This is the structure of response I'm going to provide. So if it's a weather API, it will say, okay, I'm going to reply with one number only, one floating point number, which is the weather of given the location, let's say Peoria, Arizona. You give me the location, and I return the current temperature in Fahrenheit in a floating point number, and that's it. Or it can give standardized response, and it can say, okay, I'm going to reply as JSON object, and it will say the temperature in floating point, comma, humidity, colon, and the humidity in floating point. Something more structured. It will give you the structure, and the server will provide that structure that the model client can ingest. So it's like plugging a USB device into a computer, no drivers, no setup, just, oh, hey, I know how to talk to this, and you go about your way. So let's say we are building a weather checking assistant to help decide if it is safe to go camping in Arizona. You know, Arizona can get pretty hot during summer. So we'd start by creating two components. First, the weather MCP server. This connects to the weather API, say the weather channel or open weather map, and exposes services like get current weather or get humidity or get forecast for 10 days. So these services are published automatically by the server, but you have to write a little bit of code, but it gets published along with all the features, what are the endpoints and how to call it and all those things that they advertise, hey, I can do this. And then comes the MCP client. So the MCP client really queries the servers and sees the services or which service is available and makes a request like give me tomorrow's high and humidity for Peoria, Arizona, and things like that. Think of it as like a male and female plug. So the client essentially plugs into the server. And here's where it gets really elegant. The MCP server also publishes the schema of its response like we talked about right now. So the LLM will know exactly what kind of data it's about to receive. Is it just the temperature? Or is it temperature plus the humidity? Will it be nested or is it flat? All those things. So the MCP client essentially decodes that schema and hands off to the large language model. And now the model isn't just guessing, it knows exactly what it is getting and how to reason. Previously, the problem was that when the models were interacting with those external tools, the tools will reply in non-standard fashion. So the LLM really had to guess the kind of data, and you would use a lot of compute resources trying to guess the data. And now it can just know what kind of schema it's getting, the input schema is getting, and done. And it really reduces waste, and also it's good for the environment if you think about it. So when a user asks, is it too hot to camp tomorrow in Peoria? It's a very generic question. So the model will think for a little bit, and it doesn't say I don't know because it doesn't have the knowledge. So it'll say 1 sec, I'll check. So then it'll call this online weather checking tool via NCP, grab the forecast, parses it, and you'll see 120 Fahrenheit, 8% humidity, and then it gives back a fully informed answer. Yes, it is dangerously hot. Maybe reschedule your trip when it's cooler. So all of this happens without needing LangChain, no middleman, no flaky routing logic, just direct model to tool interaction. Fast, clean, human-like. It's almost extremely fast. And this isn't just about a single API point like we described weather. This architecture is available to almost anything. You can have database structures where you can interact with a database using natural language, and to need LangChain to interact with the vector databases. Now we can directly connect to a database and the model can do all the interaction for us, provided it has the natural language to SQL translation figured out. So there are ifs and buts there that we can cover later. And also the most important part, Git. So if you are into versioning of your documents, codes and documents, some people also version their documents using Git. So this is an excellent tool. You can just say, okay, here's my new document, just version it and save the metadata. And one thing that really took the internet by storm is the Blender use. The Claude can control Blender 3D. Blender is essentially 3D animation development where you can create 3D models and then animate them. It is really good, but it is an extremely laborious process. If you have ever developed or created animation in Blender or any kind of 3ds Max Studio, all those kind of tools, Maya tools, then you probably are familiar that how laborious and time consuming it is. In fact, there are documentaries how severely underpaid these animators are. So that is totally going to be fully automated using Claude. It's not very good at this point. If you look at the videos, it can do very basic things. It cannot do advanced animation yet or advanced modeling yet, but it's getting there. So we touched on this topic in the last episode, but it's worth repeating. The MCP turned language model into really a 3D assistant. You can say create a mesh, apply this texture, set up lighting, render, and this is not quite right, move the light, render again, and the model carries out the full loop. And you can actually have human level interaction without doing click, because you'll get carpal tunnel syndrome if you like clicking those minute meshes and vertices and nodes. And it gave me a carpal tunnel after using it for some time. So controlling it by text would be a welcome change. So this model can really do all this, and it is not just fragile AI API wrappers, but really through a shared protocol, and one that really lets the model understand what the Blender can do. That's a wrap for today's episode of Machine Learning Made Simple. If you have questions or want to explore AI topics further, please don't hesitate to leave a comment. Until next time, keep exploring and enjoy your AI adventure.